when you want to.
How have you been?
Yeah,
Good to see you.
They're all human input devices. So the fact that button is actually USB keyboard.
One key
Yeah.
and a key protector, a key guard.
Okay.
A key guard,
So
yeah.
it moves the participants.
Well, this graph is about finished, but there's going to be another one. So we're not.
Yeah. Yeah, but I mean, so some folks were saying they didn't know what it did, but we've always had the sign.
Okay.
But it's not even about the sign, it's just, it's programmable too, you can change what it does, but,
Not recommended during a meeting.
yeah, I won't do it, I'm really, look, let me just close
Launch
it.
the business.
Okay.
Exactly.
Right. That's what it looks like more than anything.
Oh, it looks like the EPO switch,
EPO.
emergency power off.
Oh, yes. Yeah, that's right. That's right. On the end of a
Always
rack.
Big red mushroom.
Right. That's exactly right. That's exactly right. Okay.
This will be my first IETF where I have not taken notes in my Circus Pony software. And this is really only worth mentioning because you get to say Circus Ponies out loud. Yes,
Oh, well.
long live Circus Ponies.
Oh, first is. Oh, there it is. Okay. So we got that. And we'll get the next one, which is Mary's. Get that thing.
Excuse me.
Oh, that's right. That's right. I almost forgot to do it.
Hello.
Show me the projector.
Oh, there was a focus problem, which I will put something up and you'll see. But that doesn't help. How about that?
Oh,
Oh,
You mean, just autofocus?
that's that.
a little.
Yeah, a little. I think it's worthwhile trying to true it up a bit. Yeah.
I'll call somebody.
All right. Good. Thank you.
They get wired.
Hopefully they don't come in with a big ladder.
I don't see how else they're gonna do
They
it.
have a remote, but
We'll see.
Maybe what they'll do is give us all glasses to fix it.
Yeah.
Okay. Let's see
just
here.
move the wall.
Exactly.
Put a rope on the thing that's hanging there and pull it back or let it, yeah, I guess it would have to only be fixed in one direction.
Angle the screen. Yeah.
You know, the funny thing
Otherwise
is,
you'll get trapezoidal distortion.
Right.
my vision is so bad that I don't realize that's blurry.
It doesn't look too bad from over here, but you really can't see it. To the extent that you can read it. They look like real characters.
Oh, I see the media echo one as a whole separate protector.
It was so culturally.
Excuse me.
Yeah. Your control is looking.
Well, we're 5 minutes in.
Yeah, I'm gonna go in a moment here. I just wanted to bring up one thing. Like I said I was going to, but then forgot. The jury.
Oh, yeah. Engineering thinks I'm so cool right now. Like, really? Because I showed them how OPNFU only has one tag. Now I shut the front door. I'm like, oh my God, you guys. Seriously? They're like, we take 30 minutes just to point it. How do they point it? I'm like, okay, I'm not asking her.
All right, drop that. That's coming up. So that's where we are. Okay. Okay, folks. Time and tide wait for no man or woman or benchmarker. So we will begin.
We did not organize minute takers, so.
Well, we're about to.
Okay.
Good morning. I'm Al Morton, one of the co-chairs of Benchmarking Methodology Working Group. And this is my co-chair,
Sarah Banks.
and we welcome you to the 1000th meeting of benchmarking methodologies. Not quite that many, obviously not. Something close to about 80, I think, something like that. Maybe 70. Anyway, so let's talk about what we need to do here. We're going to meet for 2.5 hours. We are contactable, the chairs, through those 2 addresses. And it's good if you move close to the front, at your leisure. And if you're not subscribed to the Bmwg mailing list and you would like to be, there's a link right there where you can do this. Oh, thank you. Thank you for moving up. Wow. Power to the people. All right. So, next step here. The note well. Almost everything that happens in this room today that's picked up by the microphone is considered a contribution to the IETF. And therefore, subject to the rules of contributions and IETF's IPR rules. So please be familiar with those as you're making your contributions. It's always a good idea to make a timely disclosure of IPR when there is some that's relevant and you know of it as an author or presenter or commenter. So please be familiar with these best practices. Here's our agenda, and we must start first today by finding some folks who are willing to help us out as note taker, because we haven't done that yet. So is anyone willing to help us out as an in-the-room note taker? You can do that first, Sudin? That would be great.
Yeah, I think I have only notepad plus was Word document. Is that fine?
Yes. Take your notes, send them to me afterwards. I'll deal with the other stuff. No worries.
In fact, if you, the easiest way to do this is to grab the text version of the agenda and paste that into Notepad. That's what or Notepad++. That's what I do all week long.
Everyone, so I can take that in Notepad++ or Word is
Whatever
Send
works
it
for
to
you.
the chairs and they'll figure it out.
Oh,
Yeah.
fine.
Yeah.
Whatever's easiest for you.
Yeah. No, and the main thing to do is to capture key questions and decisions. You don't have to capture a full he said, she said kind of everything that happens here. It's a report more than what we call it the minutes. Thank you very much, Sudin. I believe that Marius is even going to try to do this remotely.
He's on remotely.
Okay. So the backup then is going to be a remote note taker, although it's 3 a.m. where Marius is, and I hesitate to tell you what time it is where I am because I don't know. But how about Jabber Scribes? Can we get a yes, Joel? Thank you. Joel always saves the day on this, and I've been unsuccessful in getting folks to help me out to get back on Jabber. So we've talked about IPR, and the blue sheets are making their way around the room. So keep those moving and put it in an obvious place so that new people walking in can find it. Here's our agenda for today. We'll first go through the working group status, the charter and milestones, and then we'll get into the sort of a short discussion of the working group drafts. And I modified this without renumbering a lot of things, but the working group draft on VNF and infrastructure, we'll cover that briefly in the status. Also the data center benchmarking. We were planning on a presentation on that, but it's not ready. So that we'll cover briefly in the status. So then we go through IPv6 neighbor discovery with Ron Bonica. We'll go through IPv6 transition benchmarking with Marius, who is remote. The SDN controller benchmarking performance with Sarah. Al standing in for the vSwitch benchmarking in OPNFV. A couple of presentations from Sadine about the performance monitoring, Y1731 sort of things in his first draft, and then the second one is on EVPN and PBB. Yeah, don't ask me to say that again. EVPN, and we'll supplement with notes during that time, Sadine. Don't worry about that.
Yeah.
And then we have two first-time presenters. One is Taiki Kim. Did I pronounce that right? Is that close?
Yes, that's right. And the name was the wrong, not the consideration for benchmarking IETF. It's SFC performance.
Oh, I forgot to change that. So sorry. All right. Well, I'll fix that later. But in the other agenda, I think I got it right. So this is just the slides. You know, the slides are subject to all sorts of things going wrong. So that's actually on SFC performance, which is very relevant these days. And then the final presentation is on outliers and measurements by Stenio Fernandez. Stenio's been coming to meetings for a while, and this is his first chance to give us a little discussion on things he knows. And this has come up. Oh, this has come up in discussion in the mailing list quite a bit. So we stand to learn something valuable today, and we'll continue that discussion on the list in the future. Any bashes to the agenda other than the one that Taiki has passed along? Seeing none, let's move it out. All right. So here's the quick working group status. We've got consensus on the considerations draft on VNF and network function virtualization infrastructure benchmarking. This on our charter was the first one we needed to finish before taking on any of the new virtual networking sorts of drafts. And so we need, like I said, we need to finish that first, and we're on track to do that now. So good for us. Lots of working group last calls since the last meeting. The first was on the data center benchmarking drafts, and that's where we're waiting for updates. So revised drafts are necessary, and they'll be coming soon. We also held a working group last call, the first working group last call, on the IPv6 transition technology draft. And that was received with, well received with some comments. I believe the draft's been revised now, and Marius is going to tell us about that today. SDN controller drafts. I believe that working group last call is still in progress today, I think, but it closes maybe tomorrow or something like that. Oh, thank you, Taiki. I appreciate it. So, so again, that's another one with comments from me, I believe, as a participant, and maybe a few others. Oh, Marius, yes, that's right. Okay, and we're still in progress on a working group last call on the VSPerf. That's the OPNFV project on vSwitch benchmarking, and we reviewed the draft on IPv6 neighbor discovery. So the good news is that all the working group drafts advanced with chairman sort of derived actions here. And I think that's the first time that's ever happened in the benchmarking methodology working group. So we really pushed a lot of things ahead, and I'm pleased with our combined efforts and the efforts of the group to do that. And new proposals keep coming. So you know, there's plenty for us to take up if we finish what we've got, and that's the reward of doing this work. So no new RFCs, no charter update. Sarah and I now think we have a solution to get our supplementary page back online at encrypted.net. So we'll watch the space for that fix. Here's the milestones. We're behind on a couple of these, and I just revised a bunch of milestones today, and I added this one that's underlined for Joel's approval. That one on the vSwitch benchmarking. And so, you know, we're in decent shape on almost everything here, and all we need to do now is complete the work. So, for folks who are new to the group, our scope really needs to be somehow reflected in our drafts. And the best place to put it is the security section. Why? Because our laboratory benchmarking really scares a lot of people when the security reviewers get to look at it. They wonder why we can get away with sending all this traffic and congesting things and so forth. And you know, people in general want to have some feeling for that. So this is where we explain that to them so that they leave us alone effectively. And here's the new work proposal summary matrix. So we've got 5 sets of drafts here that I'm tracking. We've got the performance monitoring benchmarking has seen some support on the list, but I've also marked a dependency there, the liaison with the ITUT. And you may have seen me send that out this morning. And our old friend Dan Romoscanu, it's kind of like an old like a reunion here today. Ron was our AD advisor for many years, and while he was, Dan was his partner in the management side. And the way I remember it was, Ron would always say, "Yeah, that looks great," and then Dan would rake me over the coals. So the same thing today. So then another draft on EVPN and PVP EVPN. I almost got it right. And some support on that for the list as well. VNF benchmarking, that was talked about briefly last time. There is a draft. Virtualized platforms, also a draft. And SFC, here, I got it right that time, Takey. It's the SFC draft is there that we're tracking. So you've got there's a proposal to do it. It's in the scope of our charter, and there's a draft. All right. So that's it on the working group status. Any questions? And seems not. So let's go back to the crazy agenda here. All right.
You did get it right on the actual agenda, by the way.
Pardon?
You did get it right on the actual agenda.
Yeah, yeah.
Good job.
Thanks. Okay. So our next one is Ron Bonica. And all I have to do is find your deck of slides here, Ron, and then we'll be in great shape. Here it is. Does anybody know the key code for full screen? There it is. Control L. Okay. Ron?
Okay, thanks.
You are a go. Please stay in the box.
Okay, stay in the box. I found that hard to do in life. Anyway, some history of this draft. About 10 years ago, there were 3 hoodlums who decided to port scan an IPv6 subnetwork, and they found that for lots of vendors, they could make a router fall over simply by doing a port scan. And the problem was an ND deficiency that was pretty widespread. Anyhow, one of those hoodlums is with us today. Oh, no, sorry. It was published as, I think, RFC 6583 or 6853, one of those two. Anyhow, most everybody fixed that bug. But a couple of years ago, we started to see customers attaching non-trivial numbers of hosts to a subnetwork. So again, our ND scaling capabilities became interesting. So at that point, we resurrected this draft. The last time we presented it was 2 IETFs ago, and there used to be a very complicated test method. Scott Bradner stood up, pointed out that it was really unnecessary. Something much simpler would have worked. So the result is this update. So let's dive into the slides.
All right.
Okay, IPv6 has this thing called Neighbor Discovery Protocol, and Neighbor Discovery Protocol replaces ARP for IPv6. What you're doing is learning the MAC address of your neighbors. And IPv6 ND is built on ICMP. There are a couple messages that go back and forth to discover your neighbors. Anyhow, the big difference is, in the days of ARP, a subnetwork typically had 255 addresses on it. So scaling ARP really wasn't an issue. It was a rare day that you saw a subnetwork with much more than 255. What do you know? Of the hoodlums we were just talking about, a second one of them just walked in the room. We're talking about the authors of that scaling of ND draft. Anyway.
Please sign the blue sheet, sir. In the back.
Anyway, an IPv6 subnetwork is always at least a /64, and an awful lot of addresses fit in a /64. In fact, that's the number on the slide, and I'm not going to attempt to even say what that number is, but it's big. So we have a scaling issue. Next slide. So basically, what we want to know is when ND is really stressed, how many hosts can you attach to a subnetwork? What happens when your port's scanned? So we did a couple tests. There are basically two tests in this environment. One is a baseline test, and what it does, you'll take a look at the picture here on the slide. This is the typical benchmark working group test methodology. You send a stream from the tester to the device under test. The device under test returns that traffic right back to the tester. And you have two procedures. One is a control group, the other the experimental group. In the control group, you're sending a stream that does not stress ND at all. You should see no packet loss. In the second stream, the second test, you're sending a stream that is exactly identical as the first, except for one thing: it stresses ND. Any loss that you see, you can attribute to ND having a problem. So what do? In the very first test, we send a stream from the tester through the device under test right back to the tester. Every packet in the stream has exactly the same destination address, so it's not stressing ND at all. You should see 0 packet loss. If you see 0 packet loss in the baseline test, you've got a problem. You have to fix that problem before you go on to the scaling test. Now, the scaling test is a little bit different. You're sending exactly the same number of packets per second. The only difference is the destinations are different. The number of destination increases as the test goes on. That stresses ND. And if you see any packet loss, you know that the packet loss was due to ND, because everything else about the stream is identical to the baseline test. Let's go to the next slide a little bit.
Okay.
And we'll talk a little bit. Let's see, can we go one slide further?
Yep.
Okay, go back a little bit. Go back to the previous slide. Okay, there's a metric that we come out of this test with, and it is NDP max neighbors. That's how many addresses can the stream carry before loss is observed. And there are a couple of other things that we're interested in watching while we're doing the test. When the stream starts out sending one destination, then 2, then 3, then 4, and it increments till finally you're sending a lot. Now, at some point, you're sending more destinations than NDP max neighbors. When you go beyond that number, the behavior of the implementation becomes interesting, and it becomes interesting to note it. What happens to the implementation? One possibility is that it crashes. That's what those 3 hoodlums of 6853 observed. That's not the behavior that you want. Crashing is suboptimal. Another possibility is that new neighbors can't be acquired, but connectivity to previously acquired neighbors remains stable. That's a good thing. Another possibility is that new neighbors are acquired, but connectivity to previously acquired neighbors becomes flaky. That's probably not a good thing. You want to, I'm not making a value judgment between the second two, but you at least want to observe which of the two behaviors you saw. Okay, next slide. So now, the baseline test is pretty obvious. Let's talk about the scaling test and how it works. The first thing you do is configure NDP with the RFC 4861 defaults. There are an awful lot of things you can do configuring NDP. Change this timer, change that timer. Figure the default values are as good as any to test with. So those are the ones we use. Then we start configuring counters. We assume that we are going to test NDP max neighbors times 1.1 destinations. So we make a guesstimate at what we think max neighbors is before we do the test. Then for each one of those neighbors, we establish 2 counters on the tester. One is packets sent, the other is packets received to or from that address. Then what we do is start the flow with a single destination. When we receive a packet from that address to that destination, we reset both counters and we keep going, and then we start the next destination and keep going and keep going and keep going. We keep going until we've sent traffic to max neighbors times 1.1. Then we stop the flow and take a look at the counters. For the first set of destinations, we should see that packets sent equals packets received. And for the last, we should see that packets sent is greater than packets received. Now, if packets sent and packets received are the same for all destinations, that means we didn't start with a big enough number of max neighbors. We know that max neighbors is bigger than the number we guessed at the beginning, should run the test again. If at the end, if some of the neighbors don't have packets sent equal to packets received, now we know we've discovered max neighbors. Max neighbors is the number of counter pairs where packets sent equals packets received. And it also becomes interesting to see, are they entries at the beginning of the stream, the one with the low number addresses, the ones that are equal, and the ones unequal, the latter ones? Or do they all, does that, do we have a few that are equal, then a few unequal, then a few equal, then a few unequal? That gives you an idea, what behavior you saw. Anyhow, the experiment is actually fairly simple. It takes about 3-4 pages to describe. Next slide. So where do we go with this? We updated the draft. Al was nice enough to do a review last night. And
Last week.
Last week, okay, I just got the slide, the mail this morning.
No kidding.
Yeah, it was in my clutter box. My bad.
Okay.
Yeah.
Clutter?
Anyway,
Did you say clutter?
sorry. Anyway, I will update the draft before we leave Seoul. And what I would appreciate is if we could get some other reviewers and maybe do a working group last call before Christmas, and we could get it to the IESG in December 2016 instead of December 2017.
That would be awesome. First off, how many people in the room have read the draft already? I see a couple hands. Okay. It would be good if more folks read it, and it would be good if more folks provided comments on this procedure. I have a comment today, Ron, which I don't think I passed along previously. Yeah, right here. No, it's not this one. When you're doing the baseline test, do you specify a load level with respect to the RFC 2544 throughput? In other words, what I'm thinking is that since you're using loss as your signal of lack of interoperability or lack of operation, we want to be sure that you're below that level.
Yes, and I think I do. As I remember, it had to be something like 1/2 of the capacity of the links between the tester and DUT, or less than that. But even if you didn't specify it, if you saw a loss in the baseline test, you know that the number's too high.
Right. So I think maybe a caution along those lines or something would be.
Let me take a look. I think I did give a number, like it has to be less than 50% the capacity of the link.
Okay.
But I forget what the number was.
And in this day and age, most of the boxes are they're bound by the number of ports.
Yeah.
If you go to 50% everywhere, it should be fine.
Yeah.
All right. Any other comments?
Oh, it was 50%? Okay, thanks.
Good. All right. That was a quick check. Yes, it was. All right. All right. So,
Okay,
so with a revised draft and some more reviews either before or after that, we can probably get a last call going.
Okay, I'll try to pass the revised, post the revised draft tonight then.
Okay.
Okay, thanks a lot.
Sure thing. Thank you. And all right. mouse. Here's my mouse.
Oh, we just have a problem. That's all.
Okay. So our next speaker is our remote speaker, Marius Georgescu. And I'm wondering if you can be heard and hear us, Marius.
I can hear you, Al. Can you hear me?
Yes, very well.
Okay, thanks.
So I have your first slide displayed, and please proceed.
Okay, thank you very much, Al. So my name is Marius Georgescu. I will be talking about the benchmarking methodology for IPv6 transition technologies. And yeah, let me just dive in. First of all, the draft motivation. So I'm sure most of you guys know about the part where IPv6 is not backwards compatible. That means that IPv4 nodes, only nodes, cannot directly communicate with IPv6 only nodes. And that also means that the internet will have to undergo a period through which both protocols will have to coexist. We have about 7% worldwide internet access over IPv6 right now, and that is a problem. Essentially, the IETF has worked a lot towards. Can you go to the next slide, please? Towards proposing various transition technologies to help network operators transition from IPv4 to IPv6, and it started with a couple in the 2000, and we now in 2015 we have a lot of diversity. One of the problems that exists for transition technologies is we don't really know how feasible they are. Essentially, for dual stack transition technologies and for, well, essentially IPv4 or IPv6 devices can be easily tested with RFC 2544 or RFC 5180. However, for translation encapsulation technologies, that's not enough. So this is where this draft is coming in, and we are proposing some extra, well, essentially configuration test setups, and I'll explain actually in the next slides. Can you go to the next slide, please? So first of all, we started with proposing a generic association table for transition technologies. There's so much diversity, you can actually reuse some of the test setups for multiple transition technologies. So we come up with this generic categorization. We have the dual stack, which, as I said before, you don't really need the recommendations of this draft for. And then we have single translation and methods like NAT64 or IVY. We have double translation like 464XLAT or MAPT. And then we have encapsulation like DSLite, mapping with address and port, and encapsulation lightweight 4/6 or 6RD. Can you go to the next slide, please, Al? So essentially, the draft provides complementary guidelines to RFC 2544 and 5180 for evaluating the performance of translation, encapsulation, transitioning technologies. So we are, from the generic classification that I presented earlier, we can deduce some associated test setups, and the translation or encapsulation will generate some overhead over the line, so we have to keep that in mind. So we have to redo the calculation for the maximum frame rate. So we presented an example on how to do that in the appendix of the draft. Also, the draft includes a tentative metric for.
Excuse me, just a moment, Marius. We're trying to find the blue sheets, and I think we just found it. to be sure people keep finding as they come in. Thank you, Bill, for persevering on that. Sorry for the interruption, Marius.
No problem.
You were saying.
Yeah, so essentially the draft also includes tentative metric for benchmarking scalability. Al has a comment about the terminology on that, and he proposed overload scalability, which I personally agreed to, and also the co-authors agreed to. So I guess we can move forward with calling it overload scalability. Yeah, we had a lot of comments from Mal in the working group last call, and thank you very much for that. We also had some support from Buhan on the mailing list, and we are confident in the current draft, but we'd like to polish it further and maybe have another working group last call. So essentially, we covered all the comments or we believe we covered all the comments that Al had. Also, our new co-author has a lot of experience in the implementation of IPv6 networks. Had a couple of comments that we tried to integrate in this version, and we will probably add some more in the next version. So one of them is an intermediary frame size, specifically 678 bytes, which is representative for production ISP traffic. Actually, we look at the statistic in the ISP I'm working for right now, and this is very accurate. This is actually a very good average for the traffic that goes over the operator's network. So also the Professor Lenche, our other co-author, updated the DNS resolution performance caching part after continuing the empirical measurements. So yeah, that's about it about the update. Moving on to the next steps. Thank you. So we still have one comment that Jacob had a couple of IETFs back, and he was saying, okay, you should look at the position of the identification tag in the frame. We're still actually looking to develop and finally have 6 transperf, as we called it for now, which is supposed to be a draft compliant implementation. So the plan is to implement, to develop 6 transperf, and then test also the what Jacob suggested, and see if putting the tag at the end or at the beginning of the frame will have any effect on the measurement. Yeah, so that's about it from me. I have only one question, so I wanted to ask the working group and Al specifically if the comments that he had were covered okay, and if there are any other comments.
Well, speaking for myself, Marius, I didn't get a chance to check, but I will. And knowing you, I'm sure that they were covered quite well. So we'll assume that for the moment, and then ask the room: are there any other comments folks would like to make on V6 transition technologies? Anybody else in the room read the draft? No. Okay. Oh, one. All right. Well, it's kind of a light turnout here, Marius. You can't appreciate that from Romania at 3 in the morning, but
I see. Okay, no problem. So if there are comments, please send them on the mailing list, and we'll try to comply. Yeah, that's all from me. I think I'll be heading to bed because it's really late. So I might be helping with polishing the notes from the audio track, maybe.
Oh, very good. Okay, well, thanks very much.
Thank you very much, Al, and thank you, everyone. Bye-bye.
Bye.
Good night. let him off the hook on notes in email.
Sounds good. Excuse me. So let's see here. That may be our last PDF one for a while. And now we go to this one, I think.
Mine.
Yes, yours. All right. So Sarah Banks is going to give the presentation on benchmarking SDN controller performance.
Do I really have to get up?
No. The camera will find you there, I'm sure.
Oh, darn. All right, so this is the SDN controller draft. Who's read this? Awesome. Who plans on reading it? Thank you. One hand. We'll make sure we get a picture of your badge at the end of the session. No worries. Next slide, please. So for those of you who are new, I don't think there's so many in the room that are new, but this is all about developing a set of tests for benchmarking, SDN controllers, looking at, of course, I think we've talked a lot about this, right? Performance, scalability, security, a little security, and reliability. And then defining a methodology for testing of the metrics and the methodology for, how do we test an SDN controller? Next slide. I know this is old news. My colleague likes to put in a revision of a history. Really, the last revision was incorporating comments from before Berlin. And then post-Berlin, we got a bunch of comments in from Al. Thank you. Some of your comments have caused us on the author's emails to sort of go back and forth a bit, which is why all of those comments aren't in a draft that you can see today. But we do have an action. The draft is mostly updated. We missed the cutoff date, to be quite honest.
Right.
And even though it's open, I thought, you know what, why don't we wait? There's a couple of things we want to run through with you. We'll do it on the list.
Okay.
But a couple of things to clarify before we come back with an answer or a response.
Great.
And then we can have one last submission since we're kind of at the end of the line here.
Right.
And then Marius, who's off, Marius gave us some comments and those have been addressed and they're ready to go in the next submission as well.
Okay.
So next slide, please. I think I kind of stole my thunder. We are kind of at the end of the line. This draft's been out for a bit. It's been well reviewed. As I said, there's been a boatload of feedback, a lot of feedback from Al Morton, so thank you. And then from Marius as well. Next slide. All right, so please, no feedback is ever too late. So if you want to take a look through the draft and send us feedback, we'd really appreciate that. Thank you. For those of you who have read it, if you have comments, please, on the list is always good. It helps Al. Since I'll have nothing as an author, I won't be touching this as a chair, but afterwards, if you have questions, find me. I'm here. I'm happy to talk about it as well. Next slide. I think that's it.
Thank you.
Merci beaucoup.
Okay. Thank you very much, Sarah. It's obvious that this has been progressing steadily since it was first introduced, and as Bhuvan likes to portray, they're always up.
Yes.
So thank you for your work,
Thank you.
and thanks to all our participants who commented. All right. Let's kill that. All right, here. So the next presentation is on the VS Perf draft, which is part of the OPNFV project. And we basically have a summary of this open source project, which is what we've been describing for Bmwg. And also making, I'm sorry, Sabine, was there something?
Yes, I was going to wait for an appropriate time to interrupt him. Thank you. Gold star for Sudin.
This is the Jira ticket system that you're looking at. And since I summarized what was going to change before doing that in the Jira ticket, I decided, let's not make a slide. Let's just bring up the Jira ticket in the OPNFV project and let folks see that, see how the process works. So that's another part of the open source outreach that's going on here, and trying to make it more relevant in our world. So we've got this good summary of all the VSPerf tests in our OPNFV project, but there's also a link that takes you to a static page that describes the test in much greater detail. And what we decided was that would end, that updating and summary, that would end with the Brahmaputra release of OPNFV, which took place earlier this year. So that's why we're kind of rushing ahead now to try to get this to reach working group consensus. So here's the things that we talked about last time. We really had a rollicking discussion in Berlin. Romkey, Romkey.
Yeah.
He had some ideas about OVS features. The scope of benchmarking does not include the ever-growing list of OVS features, but that's the best you can do. I mean, there's tons of things they were adding to OVS all the time, and we were just trying to get the switch agnostic features to be assessed here. So we also justified the length of what we called SOAK tests, the long-term tests. We mentioned that the goal was stability characterization, not the typical short-term benchmarks of performance. And we fixed the reference in the level test design document. That's what LTD stands for. The reference to point to a static Brahmaputra version of the test designs. So all the detailed stuff up through Brahmaputra is going to be available there for on a permanent basis.
Who in the room has read the draft? Do you want to take it now, or do you want to?
Yeah, might as well take it now because that's the summary. Summary of changes.
You want
Okay.
to come to the microphone? While we're waiting for him to go, in particular, folks who have read it, can you take a look at the text around in the draft addressing the length of the SOAK test? Because I think every single time we've had this presentation, we've had spirited debate over the length of that. And I like that the authors have addressed it, but I'd like to see other input and make sure you're comfortable with the text that's in the draft, please.
Okay.
Yeah, Al, this is Sudhin here. I have a question actually, because when you do the testing of OVS, but it's not catering to the OVS DB, because OVS will be spawning not in hypervisor, but now it is coming in the physical hardware, spawning multiple OVS. Using the OVS DB protocol, you are configuring the OVS in a physical hardware. So in that scenario, how do we benchmark? I mean, different controllers are there in the market say, hey, I support OVS DB. I mean, OpenFlow to manage and OVS DB to control in hypervisor, but OVS DB they use exclusively to configure and manage in a physical hardware. So in that case, how do we benchmark that? Because when I was testing it, I find it great difficulty in working with two different controllers, say from X provider and Y provider, both speaking the OVS DB protocol.
So are you saying that you in running some tests you've experienced some differences depending upon
correct
which is which?
Correct. I don't have say okay if I say throughput I have RFC 254 to benchmark this. Hey, this is based on this. These are the gaps. So right now, if you, I mean, correct me if I'm wrong. If this address that also, you know how to benchmark that, it'll be a great help.
Well, let me say that the scope of this work was controller agnostic. It uses OVSDB. So in fact the tool that comes along with this open source project, it's not just the specifications. There's a tool that runs many of these tests. Not all of them, but many of them, and that uses OVSDB to configure the switch directly. So if there's something unique with the controllers using OVSDB or OpenFlow, that's not examined here.
That's correct. So we say, okay, these are the parameters. I mean, we have to benchmark. Some of it is there. If other than the scale, I mean, how many max can be scaled, or what are the timing between you agnostic? Like if you want to benchmark between different controllers.
Oh, well, I think, see, now you're...
How many switches you can spawn?
Now you're straying into, I think, the SDN controller work, right?
No, I faced this difficulty while testing the OBS in physical hardware. I mean, that's it's just a difficulty. I'm just ventilating this. Just it's up to the others. I mean, to,
Yeah,
I faced
it
this
was just a
real
choice of
difficulty
scope for this project that they would focus on the vSwitch only.
Yeah,
And
I was testing the vSwitch OBS in different hardware
Yeah.
using different controllers.
Right.
Yeah, thank you.
Okay. Any other questions? All right. So this is also in working group last call, and folks can review the draft. You can also go to the OPNFV pages to find all sorts of things, summaries and things on our wiki. They've all been kept up to date.
Al,
Yes.
when's the last time this was reviewed in NFERG?
NFERG.
Oh, you haven't. I
never.
thought you did.
No.
Oof. Would you
No.
consider doing so while it's in working group last call? This would also allow us to get some cross-group feedback as part of the moving it through the process.
I don't have any objection to that.
Just solicit it, and see what happens.
Yeah, because that is the research area. They may not want they. It'd be good. It'd be good to know. It'd be good to know if anybody cares over there, and I'm perfectly happy to try to find that out.
Considering the
Yeah.
amount of times I get up at the mic and say, "Hey, bring that over to BMWG," I thought maybe
We should return the favor.
Yeah.
Okay. So we could cross post that basically. It's going to be a late cross post, but
That's fine.
all right. And I'll ask the document shepherd to do that.
Oh. As secretary for the group, I would be happy to do so.
Okay. I thought that might be where it was coming from. All right. Awesome.
Sued in.
What's next? Here we go.
Sued in.
Oh,
You ready?
yes. Yeah, that's what you were saying. I got it.
Say that again.
I have noted all the comments up to this presentation.
I've got you.
Good.
I will do my best suit in note-taking job while you're up here talking. You're welcome.
All right. So let me find those two decks here, please.
Performance
Here we go.
monitoring on a desk.
Yeah. Yeah. It's not that. Oh, it's this one. It's this one. There we go. Okay. Let's get rid of that. And let's go here for this screen. And we're all ready for you when you're ready.
Okay. Yeah, thank you. Good morning. And first of all, thanks Al and Sarah for the help. I mean, and once again, thanks Marius for the comments because he did a lot of things for us. Appreciate your comments. And we received a lot of comments. I'll come across, and we have modified it. So can we go to the next? So why we are coming up for this draft, and why what is the benefit? I mean, normally this is we are benchmarking the Y1731 ITUT because this is widely deployed in the service provider arena to measure the packets delay for their end customers. We say I have this, the SLA and the delay variation or the weighted delay, average delay. So how do you benchmark this? And you say X will say like this and Y will say this. There should have a consensus. You have to compare apples to apples. So we have seen the pain points in the field, and so we came across by studying the different customers because major providers and getting into that. Okay, from the problem statement we come across, okay, hey, why can't we benchmark something so that it will be the benefit to the providers and their end customer? In that we are serving the community. So this is, the next
slide.
Yeah, please. Thank you. So we have received the comments we have received a lot of comments in Berlin. So one was the increase the soak time. Sarah was asking why 6 hours. Yeah, it makes sense. I mean, soak test has to be conducted over a longer period of time to measure the various parameters like the memory leaks and all. So we have increased from the 6 to 24 to 48, 24 to 72 hours. So 6 hours to have a longer stability period to run over a period in a duty and taking the the various outputs over a period of time. So increase the soak time. So the second thing is remove the reliability part, because there's some commented like it's not needed. So we removed that section. And the proofreading, so we have done the proofreading on that. And the clarity on the graph is explained now in the latest draft. The graph, what is the graph, and it is explained properly. And the traffic details was missing, and what is why the different traffic and all, and it's explained with more precise and granular details. So can we go to the next slide? So this is the basic test setup, and the DUT, we are benchmarking the DUT, and this is a setup, and we are it's emulating a service provider network. And we have L2 VPN services, L2 point-to-point services running, and we are benchmarking this Y1731 into DUT. So can we go to the next?
Quick question about that.
Yeah, please.
What's R1 there? I can't remember what that was all about.
That's R1 as a router. It is mentioned in the this draft is also R1 as the router, and the DUT. Both are emulating the service provider edge routers.
Okay.
The DUT, and it's mentioned clearly in the draft
All
about the topology.
Okay.
And these are all the benchmarking parameters. What are the parameters? So you have to benchmark something. You have to. There should be some parameters should be there. So these are the parameters we have identified to benchmark this Y1731. One is the measurement of loss, delay, and synthetic packets under various traffic conditions. The last time, what was the traffic? I mean, we are measuring at the various traffic. I mean, because the provider's link you will be utilized like 40%, 80%, 40%, 80% of the line rate. Line rate is nothing but the bandwidth which is utilized. We're sending the traffic over that particular link. And impairment. Impairment is creating using in our lab we are using tools to drop the PDU or drop the data packet. It's emulating I mean it is kind of emulating a fault in the field, or some kind of deformed packets which is going into some kind of scenario. So in lab we are using a tool to create impairments. And second is high availability by the I mean one of the routing engine has failed, and the other kicks in a hot standby. I mean, it's high availability mode. The statistics should not be, reset. And another parameter is the soak test, which I already explained. And the scale, we scale. Last time we mentioned some scale numbers. The question asks why this. So we have generic, notations with X. We have given as N. Like it's the scale you can define. Okay, if you benchmark at this is the scale. So we have generalized the scale parameters. Next.
Okay. Actually, before we leave this,
yeah, please,
Sudhin, I've got a comment now.
Mm-hmm.
Now that you've clarified the picture, the test setup, you're going to be making loss and delay measurements using synthetic packets.
No,
So
there are three parameters. If you
Right.
Yeah.
Well, I'm just focusing on two for the moment. So the device under test is going to send out a test stream somewhere, and some other device is going to receive that test stream and either terminate it if it's a one-way test, or it's going to loop it back if it's a round trip time.
It's a loop it back.
Right. So that to me that means that either the core router or router number one here is also part of the device under test. It's kind of like a system under test here.
No, not really, because that delay will be subtracted in the measuring that, because that the packet ingressing that particular the router and egressing out, that will be subtracted out, so that the serialization delay and that delay will not be coming up.
Well,
So
I'm less concerned with how the measurements are taken in Y1731 than the fact that the scope of what is being measured extends beyond a single DUT here, single router. There's other devices in this test setup that are participating in the accuracy assessment of the Y1731 performance measurements, and it includes this.
You mean
It includes this device that's involved in the responding if it's round trip. Or if it's one way. I mean, they do have synthetic one-way delay measurements too, right?
Agreed. Yes, I'll clarify that point. That is like you are terminating from the DUT, and the packet is sending, and the client is sending, and the server will be responding it back with another PDU. In that case, yes, that box will be sending with the what all the data received and sending back to him, and he is calculating this.
Okay. Okay. So I think that's
Missing.
definitely worth clarifying here.
Yes.
You
Okay.
know, what's really participating in the test?
Okay.
In particular in the protocol that you're using, which you're evaluating here, Y1731.
So it goes there, and the client, all the operations happen in the DUT, and the client sends the PDU, and he's from the counter. He will put the other value and send it back. All the computation are done in the DUT. So I hope
Right.
this is clarified.
Yes. Well, I mean that's typical, but it's just
Yeah.
the scope goes further. Right. Okay.
Okay.
Good. Thank you.
You're welcome.
All right. So we're on your next slide.
Yeah, which I already clarified this with the various line, right? You can move to the next slide, Ann.
All right.
Thank you. So this is where impairment, which I explained with we have a tool to drop the PDU or the data packet. If we are dropping the data packet, the loss has to be shown. If we are dropping the PDU, it should not affect the counting. That's that's a parameter we are benchmarking it, because it happens like you slip it due to some congestion or something. If you drop 2 or 3 PDUs, the counting should not slip. It should not show drastic variation. It should show the exact value. So that is where it's very, very critical, super critical in that. So can we move to the next one? So this is a high availability. It's a routing engine failover. If it's one routing, it happens like this is a valid scenario in the provider environment where during the change management window, they'll be replacing the routing engine or the route processor. Or it happens like if some failure which is happening, it will normally everywhere the routers in the provider environment will be running in high availability mode. So to have a redundancy, so one routing engine goes, the other kicks in, because the data will be stored in the primary routing engine. So once the other kicks in, it should not lost. It has to have the statistics should be in sync. Otherwise, if we are monitoring probes like SNMB or any monitoring probes, it will lose the data. So that is when it's super critical in that.
So,
Yeah, please.
Sudan, so I know you're calling out only statistics,
Mhm.
but typically speaking, when you say HA in a service provider environment, it's not only the statistics, because technically you could lose something
Exactly.
while the RE switchover is happening. So packets in flight, got it.
Mm.
But you also don't mention anything about fundamental to this core data plane or control plane. I would have expected you to call out that remains undisturbed, which of course leads to statistics not being upended.
Correct.
But if you don't call that out and stats do get upended, I think you leave your tester sort of blind as to where to go and start
Correct. We
troubleshooting.
already mentioned that it should be 0 packet loss. That is where, if you are correct. I mean, if there in the data plane some packets are lost, then that is going to affect the statistics. During that window, you will be slip. That is a point. But we are in the normal high availability mode, there should not be any packet loss. That's where the high availability is. So your control plane is converged. You have the replication of all the daemons which is running in your backup routing engine, and the data plane is converged. So immediately it's failed, it will be taking over. So ideally there should be 0 packet loss.
Right. I don't remember reading that in the draft. Is that there?
It's there. It is.
Okay. I will read it. It's been a while since I've read it the first time.
It is.
And I'd
Yeah,
recommend that we had well-reviewed wording in the in-service
Software
update or upgrade
Thank you very much.
draft, and so that's probably what we want to repeat
Mhm.
about describing this ideal condition
Okay.
of no packet loss is sort of the goal. It's not a mandatory requirement.
Correct.
It's just
We will
something-
do that.
It's
Yeah.
the objective that
Yeah,
we
it's not
shoot
a
for.
conformance.
Yeah, it's not, and so it's not a conformance thing. Yeah,
Confirm.
yeah.
Yes, it's an ideal case because we are testing in the lab environment under the predetermined conditions, so that's an expected one. That's an ideal one.
Yeah.
That's ideal one.
Yeah.
Let me rephrase. That's ideal. Yeah.
Yeah. So all
Yeah.
of this is just making sure that it's clarified in the draft, because
This I will. Yes, 0 packet loss. This I will clarify. This is not in the draft, Hal. Thanks for the comment. Definitely will add it
Mhm.
because that's an important point, because that we have to mention it.
Right.
Uh,
Next slide. Okay.
that this is the scale. So we are scaling up this particular services over the services, and we are scaling it up for the X numbers, and this should work. It should not give any drastic output. All should give all should work as expected, because if you scale it beyond some X, some will work, some may not work. That is a condition when you do the testing in the scale environment. So the expectation is all the props should give you the exact result. That's the scaling is meant for.
Okay, next one.
Yeah. The soak, which is 24 to 48 hours. So increase from 6, so 48 hours is 48 to 72 hours is, it's a pretty good environment to give and take the memory readings and any core or crashes. The core dumps or the crash files, it is there. We can have a automated system to monitor it and to see that nothing is spiked up and everything is working fine. So this is one condition, and this is one of the major soak we'll be doing in the provider environment, so it has to qualify that. So I think that's it, I believe.
Okay, next steps.
Next steps, I request your comments, and last time we got a lot of comments, good reviews. One person from Cisco, he has commented, Marius has reviewed it, and we got a lot of comments in Berlin. So your comments are welcome. Because this is widely deployed in the provider environment, and once we benchmark it, this provider community is gonna benefit a lot, and their end customer, they can tell, okay, I have the statistical data with me, and this is the end. As a provider, say X provider can give his end customer, say, this is what I promised you, this is the data, the proof that I'm giving to you. Once it's benchmark, you can the community can benefit it. Thank you.
Thank you, Sudhim. So stay right there. So
Okay.
this is this is the draft, the subject of which I sent a liaison to the working group for review this morning. What we're going to do is liaise with ITUT Study Group 15, who manages and sort of inherited, but they now manage the Y1731 Ethernet OANM testing capability. And also the liaison includes ITUT Study Group 11, which has conformance and compatibility and interoperability testing in their mandate. So there's going to be 2 study groups that we're sending this to. It talks about the draft, asks some specific questions, and we'll probably hear back from them sometime next year. I don't think either one of those groups has a meeting scheduled in the remainder of this year, because they've just had their every 4-year plenary where they reorganized the place. Although nothing significant happened. Anyway. So yes. So moving right along there, that liaison's out for review, and I've given people 1 week, because it's like 1 page. If you're going to read this and if you see something wrong with it, say so right away. Dan Romascanu has already reviewed it, and we've had an exchange. So that was good. Thank you for that, Dan, if you're listening. And please.
Who in the room has read the draft? And who in the room would sign up for reading the draft? We also will get a picture of your badge before you leave. Thank you.
Thanks for the
Or
support.
just give us your name. The picture is icing on the cake.
I'm kidding. Totally. Sorry.
Yes, I'll grab a water and come for the next.
Oh yeah, please go ahead. Well,
Next is also mine, right?
it'll take me a little while to get the slides up. Feel free to grab some water. Whoop, careful. Let's see. Yeah, it's kind of hot in here today.
Yeah, it's not getting colder.
All right, EVPN.
Yeah, hi. This is benchmarking And this is a combination of two drafts. Actually, we presented in two different drafts, and this is the community asked us to combine two drafts to one, because the base, the underlying protocol is BGP and is benchmarking that. So just to add on that, so we are clubbing this two and to have a common benchmarking parameters. So there's a PBB EVPN, and EVPN, what this exactly is now, this is one of the hottest thing which is happening in the market and in the IETF community. And this is deployed widely in the provider environment as in the data center. This is the one technology which is involved in the DC as well as in the provider. And this is marrying the provider and the DC world, the EVPN technology, EVPN with MPLS and EVPN with VXLAN. So because we are widely deploying it, and while testing it, we found a lot of issues with interop with XYZ customers, boxes, and when we deploy with the various customers and we face issues, so then we discuss with the customers, say, so then they also ventilate the same things. Okay, we can have some platform wherein say, okay, like RFC 25444, okay, like there's something to benchmark it. That is the motivation behind these drafts, to come up with something to benefit not only the service provider customer and the data center community too. So that now it's booming up in the, as per the latest Gartner cycle, this data center is coming up, cloud computing is coming up. So this is the motivation. This is the motivation or the ask for writing this draft. So that thought, okay.
So I'm going to point out, I brought ISSU in for the exact same reason. And as Al reminded me gently several times, we need to be very careful not to get down the road of conformance testing, because particularly when you start comparing, you want something that you can compare apples to apples with, but we aren't trying to say, if you don't meet draft, blah, 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 then we're not.
No.
And I know, but there were little hints of it in the first drafts. I haven't read the new one since you merged, so that's on my to-do list. But the first time through, I recognized the yes, having been guilty of it myself. So just a heads up, right? It's
you can see that I was always neutral. I was always trying to benefit the community to making a generalized one, not a conformance. It's a generalized parameters. Okay, you have this A, B, C, D parameters to measure it. That's fine. We have modified. If you can look at any draft, we never do a conformance. Okay, not to have a neutral as a test community or the end customer per se. If they have to get the benefit, that was the motivation behind this.
So I'm glad any mention of that is out. Thank you.
Okay, is that answer your question, Sarah?
Yes.
Thank you. Okay, Al, can we go to? So this is already, yeah, you can skip that slide. We already explained.
Skip this one? Okay.
Yeah. Yeah, the comments have, they ask, again, there was mentioning about the scale numbers explicit. So Sarah told not to add the scale numbers, that didn't look good. So we have to generalize with X instances or with generalize with variables. So you can fill it up that variables with the numbers. So we generalized, and they said the data plane learning, they ask, okay, we are counting the MAC address in the data plane because they want some, methodology to do it. So we use the Bmwg 2889 draft, the RFC for benchmarking the data plane learning of the MAC. So that also we changed it. And combination of, both draft should be combined. That is done. And the reliability section to be removed, done. And scale part. So X in making a generalized variable, that's also done. So this is again the topology. Topology details I've explained clearly in the draft. So last time they said the traffic details are not mentioned. The traffic is a layer 2 frames, which is sending. The DUT will be acting as a multi-home P. The MHPE2 R1 is all emulating a service provider network. The DUT, MHPE2, the R1 are all the service provider edge router, the provider edge routers, and DUT and MHPE2 is emulating a multi-home scenario. And the CE1 is replicating a customer device. And the topo details is mentioned. And the traffic we are, because since it's a layer 2 traffic which is going, so we are sending the layer 2 frames with tag. So this is a, we explained this. Can we go to the next slide? Thank you. So these are the benchmarking parameters we have identified. As Sarah said, it should not be like a conformance kind of thing. It's a generalized pattern, okay? So it will be helpful for the community and helpful for the end customers and the DC customers. So we are generalizing a term like the MAC learning, the MAC flush, MAC aging, the HA, high availability, scale, convergence, and the SOAK. So for 6, 7 parameters we have identified it. So these are by how we have come up with the 7 while testing testing and going through the existing the benchmark drafts and all. They said, okay, these are the parameters we identified it, which is the need asked for this particular RFC implementation, 7432 EVPN implementation. So that's how we come up with this. Can we?
Okay.
Your question, Sarah?
No, I don't.
Yeah, the MAC learning. The MAC learning we have defined, it's like measuring the time to learn the local MACs, and it measuring the time to advertise to the remote. Because here, what is the difference from the VPLS is like any other existing layer 2 technology. It's like it happens in the data plane. Here, the difference is like the MAC learning happens in the control plane. The local DUT, the MAC comes, it learns in the data plane, but it will advertise to all the PEs in the network, service provider network as a BGP advertisement. So that's why the time taken to advertise that many MAC to others, that also we are measuring it. And and measure the time taken to learn both. If you are a bidirectional flow, what is the time taken to converge from local as well as from the remote? So that's where, the second.
Next one.
Yeah, thank you. So the MAC aging is it's there for a longer time. This particular parameter. So measuring the time once the traffic is stopped. So what is the time taken to age out the MAC? And as well as when the traffic is stopped at the remote side, and the time taken to age out that remote MACs. Like when the traffic is stopped at the remote, then the BGP will, after the aging time, the BGP will withdraw the routes, and that's going to flush the MAC table. So that time we are measuring it, because as I said, in the EVPN, the remote MACs are learned through the control plane. So that we are measuring it. The next, thank you. The MAC flush. So due to link failure and all, so what we are measuring the MAC flush time, like we are simulating the local link failure as well as the remote remote provider link failure. So the remote provider link failure, immediately the type 1 withdraw happens as well as the type 2 withdraw happens. That it's a message which is going to come and withdraw that. And what is the time? What is the time it is taking to flush out in the 2 different scenarios? Thank you. This is HA. Sarah, it's also clearly mentioned 0 packet loss in this. Okay. So in the HA is a routing engine failover testing. So emulating a hardware failure in the field, or if it's some case of some issues with the routing engine. So we are failing over in high availability mode. The expectation is 0 packet loss. That is what we have to. That means the route should not be withdrawn. There should be because if its route is withdrawn, then that's gonna flood it. So that we are not expecting it. It should be 0 packet loss. It should be hitless. That's the expectation is. So can we go to the next slide? Okay. Yeah, this scale. The scale, we are generalizing it. We are not giving any numbers. It's up to the testers to come up with the numbers. So we are testing it with the X max, like you can say 100,000 or 200,000, or whatever it is the scale. So we are generalizing it with the X scale. So so this X max should be advertised to the remote end, and from the remote end also it has to come and to converge. That kind of scale, it has to support it. There should not be any crashes, or that route should not be learned. It should not be the case. So we are scaling it to an X MAC, and that is X by 2 max from the local and X by 2 max from the remote. So the add upon to the X. So the X max should learn I mean x by 2 from local and x by 2 from the remote, and we have to get that x max scale. So it should not, that max should not be stuck or that kind of state. So it has to be there in the CAM table or the MAC table. So that's the expectation. Can we go to the next slide? Yeah, this is a convergence test. So we are scaling up into we are doing a traffic scaling as well as I mean the MAC scaling as well as the routing instance or the EVI. It's a Ethernet virtual instance. That's a instance that is where you spawn this EVPN service or you configure the EVPN service. We scale it and we send this XMAC through this, and it has to learn. There should not be any case like during the scale it's crashing or it's going to the hung state. That kind of issues should not be. That's not the expectation. It has to scale and it has to learn the MAC, and it has to be visible in the CAM table. The SOAK here we mentioned as 24 to 48, and with the scale. And we are here the difference is we are doing the SOAK because it's emulating the actual provider scenario, because actual provider it will be with scale. So we are scaling it with the EVPN scaling as well as with the MAC scaling and running over period of time. It should not be any core dumps or the memory leaks or in the hung state. So that's the expectation is. Can we go to the next slide? So requesting the community to support us.
Hi, this is Saurabh Chattopadhyay.
Yeah.
Just wanted to understand, so you're referring to some of the tests that you mentioned and the measurements specifically.
Correct.
So total number of MAC addresses that are learned, right? And then you're measuring the time that has been taken to learn those number of MAC addresses.
Correct.
Right? So how you're exactly arriving at the time, the duration that has been taken?
That's a good question, because with one measurement we cannot take it. We will be taking, as if you read the draft, we will be taking some series of measurement and taking the average value. What is the, say for example, X, say let me quote a number as such, 100,000 max. It's taking 10 seconds to learn. We are repeating this test for 7 or 8 intervals. So we get a sufficient sample size, or at 8 to 10. Normally we take 12 to 15 intervals and average the value.
Okay.
Average the value and get it.
Okay. So I just wanted to understand the criteria that you're using to ensure that all those 100,000 MAC addresses were learned, right? So is there a criteria that you're using? I mean, in a kind of way that you're checking whether the MAC addresses are learned from
Yes.
outside?
Yes.
Okay.
As I said, right, here it is different from the conventional VPLS technology. It happens in the data plane. Here the MAC comes via the two ways. One is the local data plane learning, as well as from the control plane learning. The BGP will be sending the MAC advertisement as the type 2 routes. I mean, I'm not going to the details. As some advertisement, it comes up, and then it will program the data plane. So I have to see I'm learning via my physical link, as well as through my core. It's as a BGP. So it has to sync to my MAC table. That is measured. If that is not measured, then the test won't be a fruitful result. I hope I answered your question.
Yeah, I mean, maybe, MAC table can definitely give you those data points, but I'm not sure if that's the way I'm leave it to the.
Yeah, you can help me. I mean, if you have the idea, definitely we are open to.
No, actually, I just wanted to understand, because when I was reading the draft, I couldn't understand the way the number of, how exactly you're, establishing the criteria, that number of MACs were learned. So that's what I think. If you can just add those details in the
Sure,
draft,
I'll add
thank
it.
you very much.
Thanks for the comment.
I also think he was getting at, or what I was going to get at least, is how are you measuring that? Because if you're only measuring that on the DUT, or are you using a method external to the DUT to measure that?
No, we measure with the DUT. I mean, as we said, like the MAC, it has to be learned from the local as well as the remote in the DUT.
Right. So again, I haven't read the latest since you combined the two, but the first time through, it also wasn't clear to me how you're doing that externally.
Fine, I'll do that.
Not to say we're not trusting, but we're not very trusting of the DUT.
It has to, right,
Yes.
right.
Okay,
And in
Sarah,
fact-
let me clarify. Correct me if I'm wrong. You want some external probe to check. Okay, say for if we take like 100,000 routes are there. You want an external, device or external probe to check this and give you the result. Is that?
I think you need to. I have sympathy for how hard that would be, but I think that was kind of where I was going. I kind of got the impression that's where you were going as well. Trusting the DUT, there's lots of bad reasons for that. I'm not saying you shouldn't use it as a point.
Mhm.
Yes, I know we can sit here and say all day long you shouldn't, but everybody in the lab is going to do that. Got it. But I think you should also consider having something external to the DUT being
Okay.
able to confirm
Right.
what you're
Yes,
looking
that's a good
at.
point. Can you? Normally we can see from the RT. You can. See.
I'm not saying you have to answer it here. I wasn't trying to put you on the spot with like answer it now. All I'm saying is for the next draft, would you consider
Definitely,
thinking that through,
definitely.
and we can talk a bit about it on the list as well?
Definitely, yeah. If you can throw me some light, right now I don't have that in my mind. If you can, if you are kind enough to give me some way to, I can think it. I'll be.
Well, here's the
grateful.
way to think of it, Sudhin, simply, that we've always treated our devices under test, the DUT, as a black box.
Exactly, the black
so,
box.
So all the benchmarks have to be based on what is observable externally to the black box.
Mm.
If you ask the black box for the answer, you might always get the right answer, but it might not be real.
Correct.
Yeah. So that's the
I got it.
distinction.
I got it. I
That's
got
the
it.
distinction we're making.
I got the point.
Okay.
Definitely, I'll do that. Anyway, next, yeah, we'll see that.
Okay.
Yeah, comments. I think. Thank you. Any comments? Thanks, Saurabh, for the comments, and I'll definitely explain that. These 2 comments, I will do that. Any other comments? Please.
So who's read the draft? Okay, 3. Who's read the draft and isn't from Sudhin's company? Oh crap. 1, 2. I know it's been primarily me. You have as well? Fantastic. So I think, not to say there's anything wrong with your own company for sure, but I think
No, he's not.
yes, there's 2 of us external to Juniper.
No, he's also
Fantastic.
external.
You are? Okay. So I think please, this draft needs some eyes on it. It's early, so it's not a bad thing, but it does need some reviews. And if you would consider taking a look and putting your feedback on the list, we'd definitely appreciate that.
Yeah, the one last word. This is the happening technology in both areas. The DC world as well as coming in the provider world, and it's widely deployed. So many deployed. If you name the top ISPs, they have deployed it. If you can help me, and we can help the community. That's help. Thank you.
Thank you, Sudhin.
Thank you, Sarah.
Okay. So our next speaker is new to the benchmarking methodology working group. It's Tae-Ki Kim.
Yeah.
And you've already heard the rules. You have to stay in the pink box.
Okay. Hello. Good morning.
Welcome.
My name is Tae-Ki Kim from Korean Telecom. It's a pleasure to be speaking in front of all of you. Actually, this draft we described about the benchmarking methodology for SFC performance, and we also discussed about the affecting factors for the SFC performance. The next slide, please. Yeah. Before that, I think you all of you maybe heard about the SFC, and then, but if you do not, just I refer the SFC RFC, so you can find the definition of the terms. So SF is a service function, and SFC, what I did performance the benchmarking test is a service function chain, and this SFF is a service function forwarder, which is SFC. Why they came up, it is an older set of service functions. So these days, many service functions like network functions going to be virtualized, and then we operator also have to prepare for when the VNF is going to be deployed our network. So we are ongoing development on SFC solutions. So we also think we always have to meet the SLA to provide nice service to our customers. So we thought we have to prepare for the SFC also have to meet the SLA. So why we wrote this draft. So before that, SFC, I just briefly talked the SFC. There are two types. Yeah, actually in IETF, when we going to SFC, we use NSH. It is network service header. So we put the header in front of the packet. So we decide this function, this packet is going to be this function, the SF from one to the other SF, the service have to go through that. So, but in some other way, it's not on the RFC, but they do not use NSH because we and every in service function when we use NSH, we have to decapsulate every time in the SF. So it takes some more overhead on the SF. So some part they do not use NSH, but and this time we just take a test on we do not NSH. So, okay. And then the SFF using for the encapsulation, the NSH, and decapsulation, NSH. And then CLA also classifier, when the packet through the split switches, then it classify these packet going to the 1 to what kind of SF the packet have to throw away. Then PNF is a physical network function, just like the physical network devices, such as like UTM or DPI thing. And then virtualized network functions, you also know about that. And then NSH, I just briefly explained. Okay, okay. This is the test topology we used. So. Okay, and then you can see each element that I mentioned before. And the next slide, please.
Next slide.
Yeah.
Okay.
Yeah. What we used the test traffic is we use two kind of test traffics. One is internal, and the other is external traffics. So, could you go
back?
Yeah, backward. Okay, thank you. Yeah, the first one is internal traffic. It is only existing in the cloud. So and then the host, the source host and the destination host both are inside the cloud. So that's going to be the SFC is, for example, going to be vhost 1 to. At that time, the SF is going to be like this. vhost 1 to the VNF 1, and then going down to virtual switch again, and then VNF 2, and then going down again, and vhost 2. And the external traffic we use is going to be inside. The traffic flows inside and outside, both of. Okay, so the SF is going to be like host 3 to the physical switch, and then going up to maybe we use just only that service is just PNF1, and then we use the PNF1 service. So the traffic flows from host 3 to VNF1, and then coming down to the physical switches, and then going up to VNF, and then going to host 4. Yeah, this is typo. Yeah, host 4. Next, please. Yeah. And the next, please. Next.
Okay, you got that covered? Yeah. Good. Okay.
Yeah. So before that, thought benchmarking tests, they are going to be connectivity tests first, and then we tested the performance test. The first of our connectivity, because when we training the SFs, we have to find out each SF is going to be working properly and then connected properly, and then every link of the SFs. So the objectives like the connectivity of each part of SFCs and the end-to-end SFC itself. So these tests demonstrate the SFC work properly. So procedure like send test traffic from the source host to the destination host, and check each SF and the links between the SFs. So please go to the topology.
Okay.
Slide.
Okay.
Yeah, thank you. So we have to check each links from here, and then we also have to check physical switch is going to be working properly. So, for example, SF is going to be PNF1 and then PNF1 PNF. And that time we have to check physical switches and the disk links and the virtual switches, and then this and both in and out links, and then again from this link, and then from physical switches to PNFs, and then PNFs working properly, and then going to be hosted 4. So, and then after we check the links and SFs, we have to check the end-to-end traffic's going to be flow properly. Back to the slide. Thank you. Yeah, that is the connectivity test. And then next slide, please.
Okay.
Yeah. After that, we thought what's important that we provide the services. We thought first one is A2E latencies, and the next one is A2E packet load rate, and then
Oh, sorry.
it's okay. I just named it 3-1. A2E latencies, A2E bandwidth, and A2E packet loss rate. So each functions we tested like these procedures. And then we can go back to. Yeah, A2E latency like this. And then the next one. Also the packet loss rate, also the important things. At this time, we also tested depending on the frame size, even the frame size, and also in our network infrastructure, SFC is not the only one. So we have to make many kinds of SFCs. And then we also have to test on the parallel SFCs going on our infrastructure, and then how the performance is it. So we tested on the parallel SFCs, and then next slide, please. Yeah, and then we measured like this, and then the last one is A2E bandwidth, and then there are some things like particular services such as intensive bandwidth intensive services. So we thought A2E bandwidth is a very important parameter to performance test. So we tested in these procedures. And next, please.
So all the different bandwidths here are individual measurements from a particular trial, and you're going to average those.
Not that all the different in the same test.
Same test.
Yeah, same test.
Yes.
Yeah, in the
Okay,
same
so
test.
this is just averaging the results.
Yes,
Right.
yes,
Okay.
this
All right.
averaging.
All right, good enough.
I can hear it.
Actually, my question: how do you measure that bandwidth BW1? He said you are measuring the bandwidth. So how do you measure it?
Bandwidth?
Bandwidth. How do you get that value
Yeah.
BW1?
So it looks like your procedure is to send a certain amount of test traffic,
Yes,
maybe
yes.
associated with the level you're trying to achieve,
Mhm.
and then you're looking for the condition where it has no packet loss. So it sounds like it's similar to a 2544.
Yeah, that is
throughput
where you
measurement.
have the various frame size, like 64, 128. You are increasing this and measuring it, so it won't be different. Like for each frame size, it will be different value. For the throughput, it will be a different value. Correct me if I'm wrong.
So Takey hasn't talked about varying the frame size here.
Okay, say
So it's a good question to ask. What does the traffic look like in your mind for this procedure?
For this, actually, this is very briefly routed. So we will use different frame size, and then at this the next slide, at this calculations, we also we will use a different frame size, and then we will going to averaging at that how do I say?
The same.
Yeah, and the same operation. Yes, yes. Not the averaging the different frame size
size,
going to be
yeah.
averaging. No,
yeah,
it's
thank you.
good. The last one are the factors affecting the SFC performance. We also thought I mentioned before, SFC awareness. Depending on the awareness of SFC encapsulations, like NSH I mentioned, the SFC performance going to be different because they have to decapsulation every SFs, and then the composition of SFC also. The number of SFCs in the SFC affects the SFC performance because of the transitions overhead. Like when the SFC consists of only PNFs and then only BNF, or composite of BNF and BNF and PNF is going to be different performance. And the next slide, please.
Okay.
And then when we are benchmarking the SFC performance, the operation of SF is going to be the factors, because such as like DPI and UTM, it takes many times when the packet is going on the DPI or UTM, it takes more times. So we thought it also going to be factors for the affecting the SFC performance. The next slide, please.
Okay.
Yeah. The other one is types of SFs, like the PNFs or BNFs going to be different because BNFs on the VMs, so it's hard to what is going, yeah, it is hard to assure the network performance on the VM because of the it is virtualized. So PNF or BNF, as I mentioned, is going to be the factors of affecting the SFC performance. Yeah, and also in the virtual switches or there are going to be many flow rules are there, and then the BNF is also affected from the number of flow rules in the virtual switches. So we thought the types of SFs going to be affecting, and then. This is the end of my presentation, and then please request the feedbacks. Yeah, thank you.
Yeah, a couple of comments.
Mhm.
One, so I'm also a practitioner like you, so I'm also doing these kind of benchmarking. What I realized is that there is a VNF benchmarking a work going on in Bmwg.
Yes.
There is a draft which Al has written, and it actually classifies the way the result can be presented. So it's a 3x3 matrix that's there, which talks about activation, operation, deactivation, and speed, accuracy, and reliability. And you can actually map all the parameters corresponding to those cells. So I think if you also can plan adopting that matrix, because my experience is it's pretty useful and it depicts the whole picture in a very clear fashion.
You mean the 3x3 matrix?
3x3
Yeah,
matrix that is being worked upon. Yeah.
Thank you.
And second comment is the test topology that you have presented here, and also because you have explained that you're actually looking at a hybrid service function chain, which includes physical function as well as virtual function. I think there are, the configurations and the test topology variations that needs to be created for really coming up with the kind of benchmarking data points is missing at this point. So because the test topology that you have depicted here is a very simplistic topology, but then it can vary a lot, and based on each of the variations, the benchmark data points will vary. So you can look at the way the test topology and configurations are mentioned in the vSwitch benchmarking directory. So that is a good example of the way it is being done. Although including physical functions will add to the complexity. So best luck. Good luck for that.
Yeah. Thank you for your comment.
In fact, you should probably read all our RFCs.
All of them? I mean, let's give her a.
No, I think
that a little.
I know. When it comes to the physical network functions, this is the kind of thing that that the benchmarking methodology working group worked on since 1989, since its inception. So examples of how to write down the configurations for those devices will be present in the relevant RFCs there. But yeah, I mean it's always a good idea to and you've got some of the most fundamental references here already, Teiki. So you've been doing some digging and I think for your first attempt here, very well prepared.
Okay, thank you. No other comments? Okay.
How many? One second. How many folks have read the draft? How many folks would like or would sign up to be reading the draft? Awesome, awesome. All right,
Okay.
Thank you.
Yeah, thank you.
Oh, before you go, one further point, and that is
DNFI.
service function chaining is still in the process of being standardized. So we obviously can't finish this before the service function chaining group is done.
Yeah.
And some aspects of that are actually being worked elsewhere. For example, the BESS working group on BGP is looking at providing a routing protocol for this. So that's a kind of a future dependency as well. But I encourage this work to attempt to develop it further. I also encourage you to take a look at some of the work of ETSI NFV in their testing. TST working group.
Yeah.
Yes. They've got TST 001 is a specification that's finished, and TST 004 has some relationship to this work, but this is very narrow for specific technology. So I think the two can coexist. I think it would be very good. But please take a look at 001 and 004.
Yeah, thank you.
All right. Has everybody signed the blue sheets? There's one in the corner there, I think, or in that row. There we go. Okay. Did you get the blue sheet back there? No. Okay.
All right.
Trying to get as many names as possible.
Yeah, no worries. Stenio.
All right. Yeah. Okay. So it should be the last one in here, almost. There we go. Okay, Stenio, welcome to your first presentation in Bmwg.
Okay, thank you. Yeah, that was prepared last night, so it was not on the list of presentation till this morning, I think.
So you and I were talking about it.
Yeah.
And in a time available basis.
Yeah.
So we've got some time, and you're available.
Yeah.
Thank you.
Okay. So this is a brief presentation on outliers and measurements. So I've been participating to this working group, and sometimes I see some comments on how to handle the results, and should we calculate the mean, the median, and the standard deviations, and something like that. So I was thinking maybe we can think, we can go deep on the analysis of the results. So I asked all to present something related to outliers and heavy tail data in measurements. So please, next. So the question is, the extreme observations are very common in the internet. So, and sometimes, of course, there are some performance metrics that maybe not reveal some heavy tail data or extreme observation, like packet size. So if it does occur, so it might be some error in the measurement process. So let's say packet size is like, if you're generating traffic, IPv4 traffic, and you get like 20K bytes of packet size, might be indication that there's some error in measurement. But for other performance metrics like latency, so it might not be uncommon to see extreme observations. So the question is that data sets that exhibit such large values, so it's difficult to use to analyze the data and to use the common statistical tools. And for the descriptive statistics or inferential statistics, so it's very hard to understand the data when we have large observations. So it's a decision you have to make to keep the data, to discard the data, but the first step is to look at the data and see, okay, what are these large observations? So that's the first step. So, and I said that it sometimes makes no sense to use traditional statistical tools and techniques when you have data with large values. So, as I said, calculating the mean might not be very useful. So, but you must only remove such values if it doesn't fit into your model. So model is in statistics, so you expect that the data behaves in certain way. Let's say you're generating traffic, and the interdeparture time it follows a Poisson distribution. So you might expect that the service time is exponential. So it's well-behaved data, but sometimes if the data comes with large observations, so might be something wrong, and you have to go deep in this data. So if you're confident to discard this single or burst of values, so that present these extreme values, go ahead, but you have to make sure that there's a measurement error before discarding the data. Might be those extreme values might come from the underlying phenomenon and not the error in measurement, in the measurement process. Please, the next one. Okay, so if the values come from value measurements, what should we do? So there were no errors in the measurement process, so you have two options basically. You can discard or keep the data, those data based on subjective analysis, as I said. So packet size between 50 bytes and 1,000 bytes, it's okay. If you got 6K, might be jumbo packets. I don't know. So it depends on the task you're performing. So, but you have to get this decision based on reasonable assumptions. But qualitative analysis is not sometimes tricky. So it's better to rely on some real tests and rigorous statistical methods to detect if the data, if those extreme values are outliers or not. So it's a quantitative analysis. I'm not talking about those methods here, but there are like 4 to 6 rigorous tests to test if the data, if the extreme values are outliers. Maybe in the next meeting. please. So what are the effects? If you're getting data and trying to model the data somehow, so if you remove outliers, if you see the blue dots and the red dots, the black line, straight line, is a linear regression model, so that does not consider the outliers. So if you think that the red dots are outliers and remove, you have a clear effect on the inclination of the line. So your model, you have really different models in both graphs if you see that red dots as outliers. So removing those outliers influence HMOD clearly. So you have to be careful if you're using that. You say, oh, it might be packet size in the independent variable and throughput in the dependent variable. So the lines are not convergent. So you have different models. So just be careful when you're removing outliers, because it might have a clear effect on your model. Next one. So general approach is very simple. You just have to identify the results, the values that are apart really far from the mean. So like in terms of standard deviation, so it's a very simple, this is a very simple technique, but it's not very useful sometimes. You have to dig a little bit. If you have 3 to 4 standard deviations from the mean, you can consider this as an outlier. But as I said, there are actually outlier detection in handling has been around since the 1800s, and that there are books on that topic. So the question is that if you can remove 1 or 2 outliers or something like that, if you have lots of measurements, there will be no problem. But if you have lots of observations outside the fences, we call this the fences, it might indicate that your data, your underlying phenomenon generates heavy tail data. So there's a whole line of work and tests on heavy tail probability distribution functions, and that means that the probability of that extreme values in your data set are not negligible. So you have to look at the data carefully, and of course you have to dig a little bit on the phenomena that are generating the data. So handling data from heavy tail probability distribution functions is very hard. So there's a huge debate on the statistics community. But I can show you some example. Please, next one. I generate some random values from 2 probability distribution functions, like a normal distribution is here in the lower end of the graph, and heavy tail probability distribution functions is a Pareto distribution with shape 1 and scale 1. So the y axis is mean, actually the logarithmic in logarithmic scale. So as I'm increasing the sample size, so you see that of course well-behaved distribution like exponential normal distribution Poisson or whatever, it will converge above 30 observations, 40, 100, it will converge for the mean of the synthetic data. In this case, a mean equals to 1, so well-behaved phenomenon. For heavy tail distribution, it will generate lots of extreme values. So if you say, oh, I have a sample size of 30 observation, 100 observation, and there are lots of extreme values, and I remove that, for normal distribution, for well-behaved phenomena, it's okay, because it converges quickly to the actual mean. But for heavy tail distribution, you see that even if I generate 2,000 samples in the sample set, so the mean varies a lot from one test to another test. So actually, theoretically, it never converges. So that's the main problem. So, and you see this logarithmic scale. So it has extreme values. like it's supposed to be around 110 to the mean should be around 100, but it generates like values with 10 times more, 100 times more. So that's the main issue. You have to understand if those extreme values in your data set, it's just errors in the measurement, or the phenomenon itself can generate that extreme values, and you have to look at that if you have to use those data into your model or into statistical analysis. Next one. I think the last one. Yeah, so this is the first presentation, but the idea is to understand those techniques to detect outliers, to handle the outliers, to remove or to keep it, and maybe to understand a little bit about heavy tail data in the measurement process, in the results of the measurement process. And yeah, basically what I was trying to come up with is maybe recommendations to look at the outliers in the measurement process might be benefit for the community here.
Thank you, Stenio. I think that this is an excellent follow-on recommendation from the kinds of things that were emerging in our discussions to look at just to begin to look at the distributions of delays. Our past RFCs said take the average or take one measurement or something like that, and the test equipment really surpassed what the RFCs asked for. There was ability to do histograms and so forth on latency. But when you begin to look at the distributions, then a reasonable follow-on is sometimes you're going to see some outliers. So I think this could be combined with sort of the general. We need to look more carefully now at what we're measuring, because we're likely to encounter circumstances with heavy tails, with outliers, and so forth. And then what do you do? This would be great advice, I think. We're beginning some good general advice here that we're going to encounter as we go down this path. So thanks. Comments for this, questions for the speaker? All right. Well, not today.
Okay.
But I'd like to continue this discussion on the list.
Okay.
And then, depending upon how that works out, we may have a follow-up presentation next time in Chicago, something like that, to take care of the issues that come up there and resolve them. But I think really in general, there's a good plan to work this. And thank you for raising the topic and providing your expertise.
Thank you.
Okay. Yeah, I think so. Well, we've reached the end of our agenda. Is there any other business that folks would like to raise? Any questions about benchmarking in general? We've got the room for another half hour. It doesn't have to take up a half hour. I think there's a lot of first-time folks here today, so welcome to the group. There's a very easy process to join benchmarking methodology working group. You need to have run some tests in the past, and you need to be interested in running them in the future, and this of the type of tests that we do, and according to our charter. So it's a very easy group to get involved in if you have this inclination for testing and for benchmarking and comparing the performance of devices. So welcome, and join the mailing list. That's in the title slide, and we look forward to seeing you on the list discussing some of the topics that we brought up today. Sarah, anything to add?
You did a fantastic job. Thank you.
Well, I think everybody did a fantastic job today, and we've got plenty of signatures, I think, to try to get a room next time. So appreciate it. Thank you, Joel, for jabbering, and I guess there was nobody on it, right?
Oh, it was limited.
Yeah. Okay. And Sadine, thanks for taking notes. Much appreciated.
Send your notes to me.
Yeah.
Thank you.
And we'll give you 26 minutes of your lives back to do something else fun. Thanks, everybody.
Thank you.
Good for timestamps.
Yeah.
So, we have some stuff that I did last fall.
Thank you very much. Yeah, coming up. Coming up.
So, probably not the week that immediately after you guys yet, but lots of weird North American holidays. Lower half has, just to the upper half.
Right.
Already had it.
You did. Very early this year.
We should carry those out.
All right.
I'm not sure that we want to stack them all at once.
No.
We might cluster them for things that are related to each other.
Of course, yeah. Some of the pairs of drafts will definitely move forward as a pair, like data center benchmarking and SDN. Yeah.
We're likely to get better commentary on both of them together than we are separately.
Oh yeah, yeah. Yeah. In fact, I think the only pair like that moved forward separately was the original two, the 1242 and what was 1944 and became 2544. They were many years apart. But
Oh, you know, it took a decade to sort it out.
it did. We're actually doing much faster work now. Very good. Thanks, Joel.
Are you taking any time off? Do you take time off of your job, Joel? I don't exactly know what you do, but I'm guessing you don't get much.
Yeah, I mean, yeah, I do disappear, but I try not to cluster it around sort of IETF sensor stuff, because then I just go away and I forget everything. And so that turns into the, why did we have this meeting? And what action items was I supposed to take away from it? So I think it's better for me if I actually look at the list of things that I've accumulated during the meeting.
Right.
And like try and chase those down.
Good enough.
But yeah, I take time off around all this. And we have a chain moratoriums in a lot of retail customers. So that's,
Yeah. That's